Hello, ladies and gentlemen. We're going to do 9.4b today. We're going to be talking about the limit comparison test. So this is your second of your short videos, you lucky dogs. So our objectives are that we're going to use the limit comparison test to determine whether a series converges or diverges. Shocker, we've been doing that almost every single video. But now what we want to think about is a series might closely resemble a p-series or a geometric series, but you can't quite make a term-by-term comparison. So we're going to use a limit comparison test. Alrighty, so we'll start with something other than black, our limit comparison test. Alrighty, we're going to have that a sub n is going to be greater than 0, b sub n is going to be greater than 0, then the limit as n approaches infinity of a sub n over b sub n is going to equal L, okay? And then we're going to say that L is positive. I don't like that light. I'm going to turn it off. Positive and finite. Try to get done before it gets too dark in here. And then both series are going to either converge or diverge. So if it happens for one, it happens for the other. So I think what we'll do is just start with some comparisons. All right, so for our first example, I want to show that the general, which means it's a general rule, general harmonic series is going to diverge. And that is the sum from n equals 1 to infinity of 1 over a sub n plus b. Holy cow, it's windy outside. Whew. Alrighty, so I'm going to know that a is positive, b is positive, okay? When I look at this, I can compare it to the sum from n equals 1 to infinity of 1 over n. It's very similar. And then in this case, I would have a 1 there, so my p would equal 1, and this would be a divergent harmonic series. So because this one is divergent, we're going to show that this one is divergent. So now what I'm going to do is I'm going to say a sub n is equal to 1 over a n plus b, and b of n is going to equal 1 over n. Then, let me scoop my paper up. If I do the limit as n approaches infinity of a sub n over b sub n, then this is the limit as n approaches infinity of 1 over a n plus b over 1 over n. Okay, so then this becomes the limit as n approaches infinity of n over a n plus b. And then if I divide every term by n, so if I divide this guy by n, this guy by n, and this guy by n so that I can take the limit, then I'm going to get he goes to 0, he goes to 1, this guy goes to a. It's going to equal 1 over a. And since a was positive, then that means that that ratio is also positive. Therefore, and notice that's one of my criteria, a is positive, and since this diverged, then we can say that the series diverges. Sorry, my bad, I made an incorrect conclusion. Because this is greater than 0 and not equal to 0, that's why my series diverges. Whew, good catch. All right. So one of the ways, or one of the things that we like to do with the limit comparison test is to use this for messy, I like that word, messy algebraic series, and we want to compare it to a p-series of some type, if possible, okay? So that means then, if we're going to use this process, then we have to choose a p-series that has the same magnitude as the nth term. All right, so let's go to a new sheet of paper, and we'll do an example. All right, so actually I want to just show you some examples. Let's say I have this particular series, see if I can get my paper straight, of 1 over 3n squared minus 4n plus 5. I could compare this to the sum from n equals 1 to infinity of 1 over n squared. It's got some other stuff going on, but in essence, it's the same thing. Well, in this one, p is equal to 2, therefore this guy's going to converge, so they're both going to converge. Okay? Another example might be if I had the sum from n equals 1 to infinity of 1 over the square root of 3n minus 2. Alrighty. I could compare this to the sum from n equals 1 to infinity of 1 over the square root of n. Well, in this case, p is equal to a half, which is less than 1, and therefore we are going to know that both are going to diverge. All right, and then I have one more of these examples. Let's say I had the sum from n equals 1 to infinity of n squared minus 10 over 4n to the fifth plus n to the third. Whew, that's a lot of stuff. All right, so we could compare it potentially to n equals 1 to infinity of n squared over n to the fifth. Well, this would simplify to be the sum from n equals 1 to infinity of 1 over n cubed. Well, then it's just a cute little p-series, and then p is equal to 3, and because 3 is greater than 1, they both converge. So we can take some messy looking math and kind of clean it up and make a nice little comparison. Okay? So if you haven't noticed by now, just to kind of state the obvious, when we do our convergences or divergences, we're actually doing a little bitty baby proof. So you always want to make sure that you show all of the criteria. Alrighty, I have one example, and then we are done for today. But to the list that you created yesterday, so I'm going to take a side note, add this test to your list. And in theory, you did that yesterday like I asked you to. All right, so our example, the directions are going to say, can you guess? Determine the convergence or divergence. All right, and we're going to have the sum from n equals 1 to infinity of n2 to the n over 4n cubed. That's a lot of stuff. All right, so we're going to compare this little guy. I don't know why I think that's a symbol for comparison, but that's what I'm going to compare it to. We're going to compare it to n equals 1 to infinity of 2 to the n over n squared. And this is an nth term test situation, okay? So if I took the limit of, as n approaches infinity, of 2 to the n over n squared, then this would be the limit as n approaches infinity of 2 to the n over n over n, that needs to be a squared, n squared divided by n squared. This is going to be 1 over n, and as the limit goes to infinity, this guy's going to go to 0, this guy goes to 1. Ooh, that's pretty messy. And I get 2 to the 0 over 1, which is 1. Okay? Because this was the nth term test, we got that our limit as n approached infinity equals 1, which doesn't equal 0. Therefore, I love the symbol for therefore, except you can't see the symbol. Therefore, we're going to say that the series diverges. Well, since it diverges, now I can do the limit as n approaches infinity of a sub n divided by b sub n. So now it's going to look really messy, but it cleans up pretty nice as n approaches infinity. So my a sub n is this guy. I'll use a different color. This is my a sub n, and then this is my b sub n instead of rewriting all of that stuff. So then this is going to be n 2 to the n over 4n cubed divided by 2 to the n over n squared. Whew, that's a lot of n's. And so then if I rewrite that mess, n approaches infinity, I have n 2 to the n over 4n cubed times n squared over 2 to the n. Those guys cancel, those guys cancel, and the limit is 1/4. And again, as we do this process, the limit is greater than 0, therefore the series diverges. And I think at this point, if you were doing an FRQ and you're trying to talk about this diverging, I would be a little bit more specific than I was. I was quite the slacker. Right here, I would have said which series diverged, which was this one. And then down here, then I would make an effort to show this notation to make sure that my math isn't confusing and that I receive full points, because if you'll note it, I said, therefore the series diverges, and therefore the series diverges. That is lame, and you need to make sure that you say which series is going to diverge and which series diverges. Alrighty, that is it for today. I will see you tomorrow.